Hey, it's the Cycle World Podcast. I'm Mark Hoyer, the editor-in-chief. I'm with Kevin Cameron, our technical editor. Today we're discussing the Ducati V-4 you didn't know about. The 70-year-old Ducati 65.
Yeah.
It's a very old design, but it was a V4 Ducati Apollo.
60 years, yeah.
60 years. Short stroke, big bore, push rods? What in the world? It was never produced, and there's prototypes. There's one that's floated around. I believe it's back with Ducati, and I think it went on tour. Is all I'm saying. And so Kevin, tell us what you know about the Apollo.
Well, first thing to remember is that Ducati was not the powerful, well-established technology leader that it is today when our narrative begins around 1959. Ducati had made radio parts. They made Cucciolo, the little puppy runabout. They had elaborated their motorcycle product because there was a demand for it. And they even went racing. Fabio Taglioni, the revered, rightfully so, revered tech chief of this company, came from a racing background. I think he was at Mondial for a time and probably didn't get along with the management. This is one of the problems of creative people. They have an idea and someone says, "What nonsense," and they leave.
Freaking artists.
They're not going to take that. That's right. So he saw the problem of the time, and it was a really big problem in the 50s, valve spring failure. Because a valve spring, a helical coil valve spring, is a torsion bar that has been wound up into a helix. So when you compress it, you're twisting it, the wire. And the most sophisticated steel that they had was from electric furnace ingots, selected parts of the ingot, because just like when you weld something, as the weld cools and solidifies, the impurities in the melt are driven to the center of the weld. The same thing is true of ingots. So you take a selected part of the ingot and you can have a cleaner steel, free to a greater degree of crack nucleating impurities. So Taglioni decided that he would develop an idea that had been used for a long time by a variety of companies, but never with much sophistication until Mercedes-Benz drove the valves of their straight eight racing car, W196, with it. And what this does, of course, is it opens the valve in a conventional way with a finger follower, light as can be. And instead of letting a spring hold the valve train against the cam profile as closing begins, which requires the spring to do the work, there is a second cam lobe, which is complementary to the first, and there's an L-shaped closing lever, which physically pulls the valve closed. Now, as you can imagine, this takes some mechanical precision, because to make two profiles with pivoted lever followers that have radius pads on them, that's a lot of geometry. We weren't taught that in freshman math.
It is pretty neat. The Desmo cam, the opening cam in particular, can be quite narrow because it doesn't have to push against a heavy spring.
Yeah.
So they're very blade-like. It's neat.
Yes, indeed. And of course, there are cam lobes on spring engines that are wide where they lift and narrow where they close, or narrow where the pressure is least. So, yes, that's a well-known way of doing things. So, what he did was to develop this until he could make it reliable. And they built racing motorcycles that employed Desmodromic valves. Desmodromic sort of means something like chain operated or operated by direct link, which distinguishes it from pushed closed by a spring. And bear in mind that valves do not snap shut, because if they did, their heads would come off very quickly. They're brought rapidly close to the seat during the closing process and then decelerated at over 1,000 times the force of gravity in the case of a race engine and placed on the seat.
Gently as possible.
Yes, because the valve is, think of a valve. It's a disc with a stick in the middle of it. The stick gets to guide it and transmit the opening and closing forces. And the disc on the end is like a sewer cover that you drive your car across when you go to town. It's got a 45-degree seat, and it's like a trampoline. The stick, when the valve is closing, the stick gets up to a good speed. Suddenly, the disc stops against the seat, but the stick tries to keep going. So, badoing, the valve is lifted back off of its seat by the elasticity of the valve head. Anyway, that's interfering with our story. What happened was Taglioni developed this wonderful system and made it reliable. And around 1959, I believe it is, the Berliner brothers, Joe and Mike, down there in New Jersey, were importing European motorcycles, and they, in fact, were responsible for a large part of Ducati sales by bringing those motorcycles in. And I remember seeing, when I was still in the clutches of higher education, a lovely Ducati single for which I yearned. It was a beautiful thing. So that was their business. They built singles. They built sporting Desmodromic singles. So in 1959, the Berliner brothers are looking at it's referred to vaguely as a legal judgment, that they wanted the Harley-Davidson monopoly on police bike sales to be broken. They wanted there to be competitors.
Well, there was a spec, right? The spec was written almost to exclude, to describe a Harley, 16-inch wheels, and displacement had to be X, and it had to have the tires, and it had to have a 60-inch wheelbase, I believe. There was a long, and it basically just drew a box that said, "Hello, Harley Davidson," because there was no Indian to fight with them. So
because Indian had closed in '53.
What you look for in business.
There was discussion. Some people claim that Berliners shipped 2 police Harleys over to Ducati to study it, and by '61, supposedly the Berliners said, "Well, yeah, we could contribute toward the development costs for this product because we think there could be substantial sales." So Taglioni got busy on this, and he wasn't going to do a huge V-twin because it wouldn't do what Ducati has made itself so good at doing, which is to produce its horsepower by RPM. Now, of course, you have to have good cylinder filling, which means you have to have a high flowing intake and exhaust port, and you have to have good combustion, which means the combustion chamber can't be filled with a great piston dome that's sticking up right in the way of the fiery wind that propels. So, pardon me,
yes,
that just came to me. So what did he do? He drew a 90-degree V4. Well, okay, 4 cylinders means shorter strokes than if you had 2 great big cylinders, which means the engine can rev up higher than Harley's usual, in those days, 5,000 peak RPM. And why 90 degrees? Because he knew that a 90-degree V-twin, where 2 rods share a common crank pin, can be given perfect primary balance simply by adding weights to the crankshaft. Now, there are people who, quite naturally, I suppose, imagine that Dr. Taglioni came up with this idea. Well, he did apply it. It didn't originate with him. There had been 90-degree V-twins for years and years, and I jumped up from my keyboard and went to the a bookcase and pulled out Liston's 1942 classic on aircraft engine design. And in the chapter on engine vibration and balance, he describes a 90-degree V-twin with completely balanced primary shaking force. And this is done by balancing all of one cylinder's reciprocating weight: piston, rings, wrist pin, and the small end of the rod. You weigh the rod horizontally. The weight resting on one scale is the small end weight. The weight resting on the other scale is the big end weight. So we're interested in the small end weight. It's an arbitrary distinction. So this made the resulting engine very smooth, and everyone was impressed by this, including the Berliner brothers and others who saw it running. I think they got prototypes going, but this was an engine that was difficult to package, because if you have 2 cylinders at right angles and then you raise one by 15 degrees, which incidentally was the number chosen when the Imola winning bevel drive bike ridden by Paul Smart and Bruno Spaggiari was built, which was a V-twin. Taglioni gave the V4 a horizontally split crankcase, whereas the singles have vertically split crankcases. And of course, this is because this is a 3-bearing crankshaft. What's going to support the middle bearing if you've split it vertically? So he also gave it 5 speeds. People have talked about this as, oh, it's so ahead of its time. He gave it 5 speeds because he felt he had to. It had a high top speed of 120 miles an hour, and yet it had to heave its 600-pound bulk into motion without a lot of clutch slip. So the fewer speeds you have, the larger the RPM drop when you upshift from one gear to the next. Taglioni knew that with that high top speed and the need for a low starting gear, he needed an extra gear in there. Did he invent the 5-speed? Certainly not, because in 1963 or so, he laid out and ultimately built an inline 4-cylinder 125cc racer, which revved to 14,000 RPM and made 23 horsepower. It had an 8-speed transmission. And of course, all those Hondas that were racing in the classic 1960s Grand Prix, the number of gearbox speeds just went on and on and on, particularly for the 2-strokes, where the power band could go by and you wouldn't notice it. So this 5-speed thing was a rational and correct decision. So was a horizontally split crankcase, because it had 3 main bearings. The crank pins were disposed at 180 degrees in the interest of an even firing order. in order, this engine, even when the front and rear wheels were rolled as close to it as their function permitted, like, for example, the telescopic fork not only rises, it moves backwards somewhat. And normally a swing arm, the two beams are joined by some twist-resisting structure to prevent the rear wheel from tilting to side as you go over bumps in a corner. But the wheelbase call out, they gave the thing 61.2 or 3 inch wheelbase, which is not that far from the Imola winner in 1972 because it faced the very same problems. Plus, it was a Desmo. In this case, Taglioni chose push rods and rockers because they don't rise far above the valve. So they make the engine both less tall and less long. And
well, it's a big deal. When Yamaha did one of their big V-twin Star cruisers a few years ago, many years ago now, I was on the launch and they were talking about why they chose to do push rod and rocker, and it was to limit the height of the engine. This is a very long stroke engine. It's a pretty good looking motor. So I asked the engine engineer, when the flathead was coming, and thankfully he chuckled a little. So then we could make it lower. But yeah, it's a great point about the push rod and rocker. And I think also, if you're trying to sell this motorcycle to the American market, look, I mean, we're still making flatheads. Harley's still making flatheads.
Yeah, at that time.
Yeah, so, like how just releasing the flathead, just saying no more to flatheads was a thing. So imagine going to a police department in Iowa or Wisconsin or South Carolina and saying, no, we have Desmodromic overhead cams for your police bike. What the hell? Like, how am I supposed to fix that?
Yeah.
So
it also, the rockers had the screw and nut adjusters at the tip bearing against the valve stem. So reduced to the most serviceable, accessible by the common mechanic form
easy
possible.
Maintenance. Yeah, just stick your feeler in, turn your nut, turn your adjuster, you're done.
Now, from doing what I did as a teenager and trying to measure photographs, it looks like the swing arm on Apollo was just really short, like barely over 15 inches. The swing arm on Ducati's Superbike, liquid-cooled 8-valve V-twins, which won so many World Superbike Championships, those... Where am I going with this?
Oh, swing arm length.
Oh, well, the problem with those motors was that because of their length, the swing arm could not be longer than 19 inches. And the trend at the time was toward adopting a 24-inch swing arm because it simplified some of the problems in rear suspension. That didn't affect Apollo. Apollo was given twin rear shocks and a telescopic front end, all from Ceriani, supposedly. And the steering head was braced against braking force by means of a rectangular tapered tube welded to the back of it, which descended almost vertically to an engine mount by passing between the front cylinders. And the rest of the chassis was tubular.
Stress member. Yeah, stress member. Engine was a stress member.
And it's conventional in so many ways because that's what the specification called for. The specification called for a Harley. So this is an Italian Harley, but made with a difference because it made 100 horsepower at 7,000 RPM.
And revved to 8.
Yeah.
8,000.
And not so different in a way from what I saw as a graph on the wall in Jerry Branch's the office just outside the dyno room. It described his modifications to Harley's big twin, which caused it to make 100 horsepower at 7,600 RPM. So it's these things are doable. Anyway, when the prototype was ready for test, it was presumably a prova plate, meaning test. Prova plates were put on it, and a rider took it out onto the autostrada and opened her up, see what she'll do. So, unfortunately, the 16-inch wheels with what was the section 5 or 550 inches?
Yep.
They got real hot, and then the bond between the tread and the carcass got tired of doing it, and the tire just came to pieces. And the rider said, the rear wheel is all locked up, all this rubber jammed in everywhere, and I just sort of tried to steer wrestle the thing to a stop. I'm lucky to be alive. So they detuned
melting the tires off it. Yeah.
Melting the tires right off of her. They cut back to 80 horsepower by reducing the 10-to-1 compression ratio to 8-to-1. They may also have had some cams that were more Harley-Davidson inspired. Harley-Davidson cams for the big twin have tended to begin opening right around top dead center and closing right around bottom dead center, which is a way to make unmatched torque at barely above 0 RPM, because this does not depend on ram filling of the cylinders or any kind of sophisticated dynamics. It's just a pump.
Yeah.
The valve opens, sucks the cylinder full, valve closes, compress, ignite, power.
Yeah, it's a design consideration that we still see today. Royal Enfield 350 is very much this way. The torque curve at 1200 RPM is very high. It peaks not that long later and then tapers off as it goes to its whatever it is 6,000 RPM red line.
Yes.
And if you look at a Honda Rebel 300, it's a very Honda power curve. It's much higher. It revs more, and the torque happens higher in the RPM range. It's a design decision. The Honda Goldwing, we would like 108 foot-pounds at 1200 RPM. How do we make that happen? And that's what they got on our dyno with that big flat 6. But if you go to BMW's inline 6, the torque peak is much higher. It's a much revier engine, and they've made it's the philosophical choice of like, what are we trying to accomplish? So Ducati, sporting singles, 250 Desmos, 350 Desmos, we're gonna reduce the compression. We're gonna actually soften things up so we don't melt the tires off. It's still like 80 horsepower is
that was too
fabulous.
Much still.
Yeah.
So they cut it back to 65 horsepower, and they had a runner. And heaven knows what they did to choke the poor thing off.
Well, but the first one was 10-to-1. It had 4 32-millimeter remote float Del Ordo carburetors. I wonder how the cops thought about that, the maintenance guy.
Two of them were vertical on the
vertical going
cylinders.
I mean, still fairly exotic.
So finally they get it down to 65 horsepower, and the tires are, okay. Sure, we'll do that. And mind you, the big news hit the industry in 1972 when 100 horsepower two-strokes hit Daytona, and they chewed up all the tires that could be found for them. And who won the race for 2 years during that period of, what do we do next? A little 350 Yamaha twin. And all the rider had to do was exert his normal skill, stay on his pace, and wait for the race to come back to him. And Dunlop and Goodyear had to come up with tires, belted bias construction, much wider section, um, updated, more modern tread compounds to solve this problem, which the Apollo had run into much earlier. So at this point, of course, some time has been consumed, and people have looked at this thing, and Moto Guzzi came out with a V7, and the um, teams from the Italian army and police are evaluating motorcycles for their future needs, and they all agreed V7, that's for us. And Berliner may have run out of confidence that this was going to sell, and the project was parked. 2 prototypes had been built. A lot of stuff had been checked back and forth, 2 carburetors, 4 carburetors, different compression ratios, and so on. So I'm sure considerable money was invested, but it wasn't going anywhere. The end. Now, this gets reviewed by the kind of positive journalism that we're all familiar with. Oh, what might have been if only they'd gone forward. Oh, it was pointing to the future of the superbike. And that's hogwash. Sorry, guys.
Well,
But
I mean, if we could, yeah, go ahead. Finish your thought.
it did push Taglioni to the 90-degree self-balancing concept when Ducati did decide to get on the big bike trail and have a product in that market segment, because 69 CB750, 73 Z1 903 cc's, that's where the market was going then. But it wasn't going that way in 1965. It was Triumph twins and BSA twins and Norton twins, all of which shook your fillings out. By comparison with this 90-degree self-balancing principle, which went on the shelf. Then in the very early 80s came Dr. Taglioni's second V4, the Bipanta, Bipantah, 4 Panta cylinders on a V4 crankcase. And they were able to, it was a 2-valve, just like the Apollo, because that Taglioni didn't see the point of 4 valves. He'd had some truck with them. His 125 inline 4 had 4 valves, but it just seemed like too much complication to him. And why didn't the 125 inline 4 go anywhere? Because at the time that it was making 23 horsepower, Shorichiro Irimagiri's 125.5 was making 32 horsepower at 20,000, and the following year 34 horsepower at 20,500. So it was a different league. Ducati was not yet an industrial manufacturer in 64. Honda was. Honda could produce these fabulous eruptions of successful technology because they could afford it and because they were putting their name before everyone in the world as associated with high technology and racing success. So this new V4 didn't go anywhere either. I think it was canceled in 82. But what lives on in a very big way is the 90-degree V4 self-balancing, because if Yamaha does decide to drop their inline 4 in favor of the V4 that they are testing, every constructor in MotoGP will be building engines of the same architecture as Taglioni's Apollo. And of course, in World Superbike use, they found that they had 48% on the front wheel, 52% of the weight on the rear wheel, and the things pushed like crazy, and they showed signs of instability. And so every year there was a new frame, a new way of trying to move the motor forward. The radiators got slotted, so the cylinder head came forward. They made the exhaust valves shorter than the intakes so that they could tilt the valve cover to keep it away from the front tire as the suspension was compressed. And I remember seeing on those race bikes rubber from the front tire on the front cylinder's valve cover. So that's pushing it.
Yeah, it is pushing it. Well, the twins at the very end, the Ducati V twins, had tremendous bores. You know, what were they
112, maybe
100? Yeah,
116.
112.
They were
116.
bigger than a big block Chevy piston.
So, you know, they're going for displacement with keeping the engine short, which of course was one of the reasons that the Apollo had an 84.5 bore and a 56 millimeter stroke, was to keep the height of the engine low. The Panigale, the current Panigale, such as this one parked behind me, is 81.0 by 53.5. So it's, you know, 2.5 within 2.5 millimeters of the stroke value of that guy.
Yeah,
it's pretty great. Of course, they rate that one at 208 at the rear wheel. And I think the final story we did on the Apollo a number of years ago says the final milder cams, reduced compression, 7-to-1 compression they went to. Milder cams, it dropped power to 67 horsepower, and top speed was about 100, only 100. And what it did was change the power to weight ratio to less than your average British twin of the time.
Yeah.
So it was a little bit ponderous, but, you know, so were Harleys, really. So
yes.
at the time.
Franco Fane, who spent his life at Ducati, said that it handled like a truck. And I remember Yvon Duhamel saying of the long swing arm Kawasaki, he said, it handled like a lumber wagon. And so, you know, riders, unless they've been properly instructed by persons of higher pay grade, will speak the truth.
Yeah, I don't have the dimensions of the engine, but, you know, looking at the photography of it, we'll do our high-tech graphics here. But the engine here's the cylinder way up here by the front fender, and then it just keeps on going, and it's just real long. And then you have that nice short swing arm, and you know, when you think about Yamaha R1 of 1998, they stacked the gearbox shafts so that they would be vertical, and I believe that swing arm, they were very proud to say it was 22 point something inches.
Yep.
And they were allowed, then shortening the engine, they put more of the weight forward, and then they were able to extend the swing arm.
Yamaha started stacking the gearbox shafts in its 500 two-stroke GP bikes in '84. The Guzzi V8 and all of the Guzzi horizontal singles have their gearbox shafts vertically stacked because of this length problem. Anytime you do a V engine, it's like you're pushing the front and the rear wheels farther apart. But the criterion of wanting quick turn in and rapid steering wants to bring them back together. So,
well, that was one of the V angle of 45 for the XR 750 was actually one of its advantages, because you could move that engine around more than a 90, which, you know, clink clink clink. Yes. And during all the circa 2000, Dirt Track was experimenting with super trackers, so they were trying to get, you know, just regular old off the shelf Honda, because Honda was doing Super Hawks, and there was TL1000 Suzuki's, and et cetera, on and on. And so all those guys were trying flat trackers. And of course, somebody showed up with the Ducati powered machine, and apparently the rear weight bias was a little much for that particular bike. So.
Well, that was a problem for the bevel drive, because with the engine as far back as it was, the heavy part of the engine being the crankshaft and crankcase with the gearbox on the back of it, they ended up with quite insufficient weight on the front. And so they had to recover stability by giving it a 30 or 31 degree steering head angle and 4.5 inches of trail. And that's where Cook Nelson got that phrase about cornering as if it's on rails, because you didn't really have an option. Once you'd set that thing into a corner on an arc, best to leave it there and travel around the arc and exit onto the straightaway. Whereas when he went to Japan to ride the RG 500 race GP bike, he said it was like, and horsemen and women say this too about the best horses. It went where I looked. And lots of horses can jump a course with the rider as passenger. As soon as they know what the sequence of jumps is, they can do it. There's two brains and one goal, which is to get back to the barn and eat. Anyway, one of the other problems that had to be dealt with was in the 1930s, early 30s, AJS decided to make an air-cooled V4 as a high-po production bike. It was 500 cc's, which was considered fairly good size displacement in those days. And they found that when they tried to tune it up into a racer, that the hot air streaming back from the front cylinders, I think this had a 55 degree V angle, overheated the rear cylinders because they're supposed to be cooled, not heated. They're getting hot air off the front cylinders. So they had to reduce the compression ratio on the rear cylinders to 5.5 to 1 to stop it detonating. Sounds like the Iron Harley at Daytona in 1970. The one that Dick O'Brien said, you'd switch the lights off in the dyno room after a run, you could see where the cylinder heads were. So they finally water cooled that bike. It was really ambitious, complex program, and they eventually came close to making a winner of it. It was very powerful. But no trying to cool the rear cylinder with hot air off the front cylinder, which is another reason for the 90 degree V angle. The cylinders in the rear had cylindrical fins, so air from coming over the top of the tire into the space above the front cylinder could pass through those fins. The front cylinder, which was nearly horizontal, had axial fins that were parallel to the cylinder axis, just as Moto Guzzi's always had. So
we grabbed a technical drawing for one of our stories. Again, high-tech graphics here, but it shows the fin spacing as I believe 9 millimeters. So
yeah. So that was a problem avoided because Taglioni knew his history. He knew what people had tried, what had worked, what had not worked. People in the design business talk endlessly with others of the same inclination when the occasion arises. Accumulating that knowledge has been a wonderful feature of the development of the motorcycle. So at one point, Massimo Bordi writes a engineering thesis, in which he proposes joining Taglioni's developed Desmodromic valve train with Keith Duckworth's narrow angle 4-valve, flat, fast burn combustion chamber to make something what's that word? Synergistic. Each part benefiting from the other so that they are bootstrapped to a new level.
Yeah, the Cosworth, Cosworth combustion chamber and 4 valves and tumble and all that stuff is
Yes.
we're living on that today. So,
Because practically every motorcycle, car, and light truck engine uses a Keith Duckworth inspired combustion chamber, because not only does it work for racing, it can produce good results for emissions compliance. Now, that's not a bad combination right there. Some flexibility. So, Bordy went to Cosworth and spent time there talking with engineers and learning all about it, what they were willing to tell him. And he was hired at Ducati, and he showed both ambition and guile, we're told. And he encountered the anger of Dr. Taglioni, who saw Bordy as a rug merchant bringing false gods, hoping for worshippers to arise at Ducati. And there's a story told that one day the Bordy folk who were building the Otto Valvole, the 8-valve, liquid-cooled 90-degree V-twin, were out testing, and as evening drew on, they returned to the workshop to leave the motorcycles there and go to their well-deserved dinners, only to find that the workshop was occupied by Taglioni sympathizers who would not let them in. And this is great, because the notion of a fight breaking out at Honda or one of these well-organized corporations is, well, not very likely. But these are the Mediterranean shores. And there was supposedly a punch out, followed by a certain embarrassment and a return to cordiality. At one point, when the liquid cooled 8-valve was needing dynamometer access, they sent Taglioni on a sales trip to Russia. And so it's unfortunate that these enmities develop, but Taglioni, the things he knew, he had learned by the most practical means. Therefore, he had good reason to believe them. One point of overlap is that looking at the downdraft angle of the Cosworth-inspired liquid-cooled Ducati, he decided to try it on one of his V-twins and found that it was an improvement over the classic cross-flow system, where here's the valve stem, the valve head is here, and the port just comes up to it and goes. And the late Kenny Augustine told me more than once, he said, I can get more air through a cross-flow setup than most people can get through a downdraft. So, okay. There's a lot of ways to accomplish the same goal. In this case, Ducati powers that were at the Milan show one year were looking at what was on show and trying to forecast what the future might be. And they decided the future was liquid cooled with 4 valves per cylinder. And at that point, the Bipanta, the 4-cylinder Panta V-twin V4, was being canceled. Taglioni was retiring, and he, of course, didn't go far. He was always there for the faithful to consult, but it was an 8-valve future from that point.
And I think you saying this reminds me, of course, that the bridge between the eras was the great Gigi Mengele. So Mengele did a lot of the drawing for Dr. T. I mean, Dr. Taglioni, of course, great designer. But Mengele was really quietly credited with a lot of the hard work. Making the Desmodromic valve system work on the 4-valve was actually, I believe, a Mengele project, and it was complicated. And my friend Ed, who works on these things still to this day, says setting clearances on a 4-valve of the era is a real, the Desmo valve clearances is a real headache.
I
Lots
went
of
to the service
Billy
school
belts.
for the D16, the production bike that was a
Oh,
racer
wow.
replica. And of course, they have a special plier by which the essentially press fitted collets that fit on into the groove on the valve stem, and then their taper fits into the
Yep.
I can't call it the spring retainer, the action platform.
Yeah.
Um, you take hold of that assembly and crunch, it goes home solidly.
Hmm.
Whereas if you were assembling it without those pliers and you sort of tapped on it and so, well, I think it's mostly there, and assembled the engine and clearanced it for that, after it had run for a minute or so and those valves had been knocked back and forth, clearance would appear, noise would be heard, and you would think, oh, I have to do it all over again. So, hence the pliers. So, I think that it's not surprising that some recent Ducati products have valve springs again, because of course valve springs have come a long way since the 1950s.
100% makes sense. You know, I mean, we
Yep.
can all love the religion of Desmo, and it's essential to the character of the brand. But you know, Ducati's really I think essential Ducati to Ducati's brand is high performance. So we had high performance Desmo singles, and then when it came time to make a twin, Ducati suddenly became a twin company.
Yep.
And when it became time to make a V4, it's a V4 company. It makes perfect sense. And you want to throw spring head at it? Why not?
Yeah.
I mean, honestly. So the great Bruno Di Prato, our Italian contributor, he worked at Ducati. He brought Ducati the Super Blend bearings when they were having problems with their bottom end back in the roller days, you know, circa 72. Dr. Taglioni was the best man at his wedding. So he,
Yes,
you know,
that's right.
they were friends. They were
Yep.
friends. And we had him do a story on the Apollo, a short story for the print magazine a number of years ago. And he said, the engine was virtually vibration free. Dr. T once told me about the day the bike was unveiled to U.S. dealers, and one of them mentioned vibration. In response, Fabio reached in for the change in his pocket, extracted an American quarter, and laid it on the tank. He proceeded to whack the throttle open, and the quarter did not move.
Yeah.
That's pretty good. And then what we were talking about, the handling issues, he said road tests were conducted by the great Giancarlo Labrenti, one of the best Ducati technicians ever, who always reported high-speed stability problems.
Yes.
By his own admission, Taglioni was a supreme motorist, but not a chassis specialist. So power and torque were astonishing, but short swing arms and 5-inch sections, 16-inch wheels,
600 pounds.
600 pounds. It led to some entertainment value.
But this is how a tradition is formed, and I think that it would be foolish to imagine that a two-valve Desmo arrangement should carry forward through time, because that's producing a vintage machine, and it's then going to become a veteran machine, and eventually it will be completely forgotten.
Yeah.
At one point, the decision was made by Claudio Domenicali that Ducati would compete with the manufacturers of big, powerful sport bikes head to head, with no reliance on, but it has European flair. No, we have the horsepower.
Oh, the
So,
1098. Yeah, the 1098 was really the the stick in the sand there. The 1098 came along, and they geared it for They geared it for the quarter mile. It was, I think, the first 10-second Ducati we ran. And yeah, they were just going like, you know what? Because they, prior to that, in talking to, oh, shoot. I mentioned this guy quite a bit. Anyway, the test rider that I was dealing with, sort of circuit, mid 2000s, he said that every Ducati we gear for top speed. That's what we do. Mm-hmm. And that was a philosophical change for the company. The 1098 really was a huge change for the company because it ended the Terblanche era, which had, ended with a shouting match with Claudio and Terblanche, Pierre Terblanche, upstairs, in his office, and things got to change, and I don't want to change, or whatever happened there. It was the end of the era.
Yeah.
And then there's the fella Grosbeek, who's at BMW now, who just did R12G/S and that whole platform and those models. He was part of that design team. Great guy. But he was at Ducati at the time, and I was able to talk to him about the 1098. And I said, oh, the 1098 was a perfectly conservative, cozy blanket. It was an apology to the Ducatisti for the 999, the 999.
Yep.
Looking back at it now, I mean, even at the time, I could, cerebrally, I could understand, like, yeah, this all makes sense. But that wasn't really why we were necessarily in the Ducati camp. It didn't make sense. I mean, a 916 made no sense. It was rock hard. Everything was rock hard. The clutch was rock hard. The seat was rock hard. The mufflers were under the tail section. And riding one of those, the riding position was pretty brutal. The pegs were very high. Riding it on the street it could be fun, but it wasn't, wasn't easy. But man, you get on a 748 or a 916 and you went to a racetrack, and for 20 laps, it was pure bliss. It totally did, absolutely made perfect sense. But it was sensual and experiential, not necessarily cerebral. And I think there was a lot of cerebrality around the 999, and the 1098 was the bike that said, we're going to publish real weights. We're going to publish real horsepower outputs, and we're going to nail quarter mile. We're going to compete head to head with the Japanese.
Yeah.
And that was no doubt, that has to come from the top. It has to come from the top. It's like, I talked to a Harley executive years ago, and I said, why do these bikes have to be so heavy? Why does a Harley Big Twin have to weigh as much as it does? Can we not make a die-cast aluminum part that's stronger, lighter, uses less material, is easier to ship? He's like, yeah, absolutely. And he went to his snowmobile and he grabbed this beautiful cast part that was to hold the handlebars, I think. And then he showed me the previous steel part. He's like, this is cheaper. It's lighter. It's more rigid. Everything is better.
Yes.
And I said, yes. And he said, yeah. I said, why doesn't the weight conversation come in the room? And he said, it hasn't been a priority, and it has to come from the top.
Yeah.
And that's it. And Claudio made it come from the top. And I think the respect I have for Claudio Domenicali is, came in as an engineer, has a practical mindset, and
he's been good at whatever job they gave him.
Yeah. And as much work as I am sure that when he got made CEO, when you're an engineer, even if you're a really talented leader, you're still an engineer. It's like being a writer. Like, why do you like to write? Well, I like to sit in a moderately lit room by myself, stare out the window, and think of things to say. We're not negotiating contracts. We're just trying to tell a damn good story. And, an engineer wants to sit and it's like it's like Bordy wanting to say, I want a DFV head, 4-valve head on top of the Speed Twin. Let's go.
Two progressive concepts unified into one.
And so for Claudio, it's great because he has I think the leadership of a company has to have that molecular or DNA connection. It has to go to the soul of the company, which for Ducati would be great engineering and figuring out what those essential truths are, because they have found the essential truths. If you look at MotoGP, I mean, okay, Mark Marquez. I mean, have we ever seen a guy do this? I don't think so. But
such as uncrashing.
yeah, but he has the tool to get it done, and Ducati is the tool to get it done, and it's because they have discovered and unrelentingly focused on the essential truths that make a motorcycle work within the
Yep.
confines of whatever. If the telescopic fork is somehow a weakness, well, we've pounded the weakness into submission, and we're using its strengths to make it work better than anything else could possibly work as a front suspension, because
Yep.
it's not a perfect way to.
No,
I mean,
it's
it has
filled with compromise.
it's filled with compromise, and yet here we are.
Yes. And many alternatives have been tried. It was interesting to talk to Pierre at Terre Blanche at the Milan show one year about the 999. I think this was probably around the time of its introduction. And the way he described the work was he said, this motorcycle has been accumulating changes since its inception. And a major part of the work that I've done here is that when three or four bolted together pieces are supporting a rectifier, an ignition box, what have you, I've found a way to make a single part do all those jobs. I've tried to rationalize it. I've tried to route things in a way that makes sense for assembly and this and that. And of course, I don't think Peter had much truck with single-sided suspension. I remember Gary Mathers, for so many years, American Honda's racing manager, saying, if you want to see the results of stress asymmetry, go to turn 8 at Willow, or whatever turn it was. Because if the swing arm is supporting the wheel from one side, any slightest flexibility is going to result in self-steering. And I don't think Peter wanted any truck with that. But Ducati buyers wanted it.
Yeah, that
They
was
thought 916 just looks great to them.
Yeah, especially at that time, VFRs and RC30s, you just thought, oh, this is the coolest thing. It's like this big
And such a
thing.
simple shape.
Yeah.
A
And you could
lovely,
pull the wheel
simple
off.
shape.
Like I loved it. I had a 95. It was the first new motorcycle I ever bought was a 1995 Honda VFR 750. And it was, you had to take the exhaust pipe off, but it was 2 bolts and the silencer comes off. And then it was 4 lug nuts. You don't have to disturb the chain. Wheel just comes off, you do your tire change and move on. But Terre Blanche at the time said, we talked about the double-sided swing arm of the 999, and he said, as you were pointing out, he was pressing toward the rational, and they tested the 999 with a single-sided swing arm and the dual arm that it ended up with, and they got faster lap times with the dual arm.
Yep.
And so everyone insisted, or he insisted, that it has the dual arm because it's faster. And, you can get that through. But that 1098 came out, and what did it have? Single-sided swing arm. Yeah. Marketing said, hey, make that work, okay? And that was part of just saying, hey, we're back. We're going to.
Well, as soon as MiG-21 and SR-71 had that intake cone in front of each engine, got to have that. That is the greatest shock cone. And I think on the SR it moves 26 inches or something from one extreme to the other. The aim being to hold the shock in such a position that it decelerates incoming air to subsonic, because it's a sonic engine in there, a subsonic combustion system. So, but our sense of things is not the same as a design optimum. And so there is definitely room for art, because the person who designed the 916 made it look the way it does was an artist. and no question about it, as well as an engineer. And I think I've said this before. It's possible to be suspicious of art in products, devices that have to perform a certain task. I don't like swept wings. Well, if you want to go this fast, I've got it. F-104. Oh, the problem being that it's hard to find an engineer who has that sense of how things will look to people and can build that into the functioning of the device, which is intended to move performance forward. And I think that the firearms of John Browning show this same sense of the rightness of things in their design.
Caesar Guerini Italian shotguns. Oh my God.
Yeah, I went to a gun store and I looked at modern automatic pistols. To me, they look like staplers.
They do.
They have
they totally do.
Big crude trigger guards with the room for a person wearing Arctic mittens to put all his fingers through there, and the thing just has a club-like look compared with the 1911, which, with all its faults, is still much sought after by people who fancy that sort of thing because it's a timeless design. Occasionally, it'll catch one of the empties in the ejection port, and that means it's obsolete because there are later designs that don't do that don't stovepipe. But I think this ability to combine human sensibility with engineering flourishes in Italy to a wonderful degree. I've always been impressed with that. When I was, as I said, still languishing in higher education, I saw that 250 single Ducati, and I thought, oh, why don't I have the sense to quit this, get a job, and get one of those motorbikes?
Yeah. Well, I mean, 1994, Massimo Tamburini and Ducati unleashed the 916 upon the world, and everything else looked clunky.
Yep, clunky. Can't be helped.
Oh, it was essential. Well, that's the Ducati Apollo, folks. That's we did extend our topical discussion outside of that, but always linked back to Ducati. So Ducati's V4 happened long ago, and we appreciate the new one. Oh my gosh, you can't even. This is like time travel. It's supernatural horsepower. That and the M1000RR, completely different proposition than other leader bikes that have come before in standard form. They're just, it's mind-boggling how much grip, how they turn, the forces on the brakes, the forces in cornering, the forces on acceleration.
And the achievement of ultimates raises all boats, so to speak.
Yeah. It's a knockout. Well, I know you said this earlier. Oh, what could have been?
Yes.
But imagine that. Imagine a V4 pushrod Ducati. What if Ducati became a cruiser company?
Now a movie in theaters this summer.
Yep. The original Diablo, folks. That's what it was.
Yes. Right.
So, well, thanks for listening. Catch us next time. Let's get down in the comments. If you're digging the podcast, share it with your friends. Help us out with that. And jump in the comments. We love reading them. I'm always in there. And we'll catch you next time. Thanks for listening.